Today, I'm going to tell you the results of a research project I recently worked on. This research project is about cloud development environments, which is something that I didn't know about until recently. The reason for that is because I had a different solution that was working before. Basically, you need certain software on your computer in order to execute Python code. Like you need the Python interpreter, and you also should probably have an interactive development environment, which is called an IDE. And I got that before from the Anaconda distribution. You can download it from the Anaconda website for free, and I would have my students download that, and we'd have everything that we need to code in Python and complete my courses. The problem is that from time to time, I teach at large financial institutions, and they have firewalls that prevent their employees from installing new software on their computers. That means that in order to get my students the software that they need to complete the course, I have to go to IT and ask for their help. And in the past, even when I've gotten IT's help, my students have still had problems. I assumed that that's just a natural consequence of working with these large bureaucratic organizations, and so I just tolerated it. Until recently, I got a new job with a big Japanese bank, and my partner who gave me the job, I gave her my software requirements, and she responded to me and asked, is there any way to get around this using a cloud-based solution? And I thought, that's a great idea. I never thought about it. So I started doing some research, and I discovered this new category of software called cloud development environments. It goes by different names. Some people call it web-based interactive development environments, but the name that seems to be sticking for this kind of software is a cloud development environment. So I started looking to understand what alternatives are available, and I found one is produced by Anaconda. There are many others, but I honed in on three produced by Anaconda, Google, and Microsoft. And so in this video, I'm going to tell you about those three options that I looked at and considered, what I thought was good about them, what I didn't like about them, and the one that I ended up choosing. So first, I'll tell you about the Anaconda solution. And before I tell you exactly what it is, I'm going to give you a little bit of background. In 2022, Anaconda they acquired a company called Python Anywhere that had developed a CDE, a cloud development environment by the same name, Python Anywhere. 5 months after that integration, Anaconda announced Anaconda Notebooks, which is the result of them using Python Anywhere's software, integrating it with their system, and producing a new product. So Anaconda Notebooks is a hosted Jupyter Labs service. That means that it's Jupyter Labs, which is the same company that produces Jupyter Notebooks. So users can use Anaconda Notebooks like a Jupyter Notebook. It's based on the same exact software because Jupyter Labs is open source. So Anaconda has integrated that into Anaconda Notebooks. It's hosted. That means that users who use Anaconda Notebooks are using Anaconda's processors when they compute their code, when they execute their code, and they also are able to store files on Anaconda's cloud storage. So it's a hosted Jupyter Labs service. Anaconda Notebooks also come with all of the common Python packages installed just like the Anaconda distribution. And so my bias was to use this solution because I'm familiar with Anaconda. I like the Anaconda distribution. It's a cloud service. So I thought that it would work well for my students. But the problem is Anaconda places a daily limit on the amount of computation that users can use each day. And the limit is 1,000 seconds. Which works out to 16 minutes and 40 seconds. In a basic Python course, that should be more than enough. And even in a machine learning course where you're processing large amounts of data, you're probably not going to hit that limit, but I didn't really want to risk it. It seemed like I might get close if I'm having students process huge data sets. So that was a detractor. And then the other problem that I ran into is Anaconda makes it easy for students to share their notebooks, but I didn't see an easy way to share files using Anaconda's cloud storage system. And the problem with that for me is I'm teaching students at these banks and I need to send them data files to use for the class. If I can't send them something through Anaconda's cloud storage, then I have to email them the file and then they have to upload that file to Anaconda Notebooks. It might raise warning flags in their corporate system. If you're uploading files from your work computer to some third-party website, somebody in compliance might not like that. They might get upset with the employee, they might get upset with me, and I'd rather avoid that. So even though I had a bias to use Anaconda Notebooks from the beginning, for these two reasons, I decided not to, and I kept looking. Next, I'm going to tell you about Google's solution, which is Colab. Google produced Colab originally back in 2014. I think they released it to the public 2017 or something like that, and they've been quiet about it. They have not promoted this solution, but it is a cloud development environment. It's also a hosted Jupyter Labs service. So it looks like a Jupyter notebook. You log in using a Google account and you use Google's processors. You can connect your Google Drive for file storage. So that seemed like it might be a good solution. And the thing that was most interesting to me about Google Colab is that it offers a native integration with Google's AI. Large language models like ChatGPT or Google Gemini are changing the way that people code, obviously. And I'm still trying to figure out what to do about that and how to integrate that into my instruction. But if I'm going to be teaching Python, I need to address the changes that are happening in this area. So I thought if I use Google Colab and I have that native integration with Google's AI coding assistant, that would give me an easy way to integrate these changes into my instruction once I figure out what to do with it. The problem with Google Colab is computation, for one. Unlike Anaconda, Google Colab does not place daily limits on users. It actually doesn't publish limits at all. It doesn't guarantee how much compute you're going to be able to use on any given day. It reserves the right to fluctuate the amount of compute that users are able to use at any time. And so what that means is I could be in the middle of a class where my students need to process large amounts of data, and Google Colabs could reduce their processing speed dramatically. And I can't take that risk, so that was a deal breaker for this solution. Finally, Microsoft. I'm gonna give you a little bit of history on this one also. Back in 2015, Microsoft released VS Code, which is now a popular IDE. It's the most popular IDE for data science, according to a JetBrains survey back in 2023. So Microsoft created VS Code. In 2018, Microsoft acquired GitHub, which is a collaboration platform for software developers that does a lot of things, but it allows people to share files, to put it simply. It's one of the things that it does. Then in 2021, GitHub released Codespaces, which is a CDE, a cloud development environment based on VS Code. It's basically VS Code hosted on the cloud, meaning you can access it through a web browser. You're using GitHub's servers for storage, and you're using their processors for compute, which really means you're using Microsoft Azure processors, and Microsoft has a ton of computation power, so that's a good thing. But Codespaces is VS Code on the cloud, pretty much integrated with GitHub. Unlike Anaconda Notebooks and Colab, because Codespace is based on VS Code, users are not required to use the Jupyter Notebooks environment. VS Code does offer a Jupyter integration, so users have the option to use a Jupyter Notebook, but you don't have to. So you have the same functionality, but more flexibility. So that's a benefit. Codespaces also provides 7 times, actually more than 7 times, the free computation as Anaconda Notebooks. The limit's also calculated by month, not by the day, which means if I'm teaching one Python class that's basic and introductory, or if I'm teaching 3 days of hardcore machine learning, my students are gonna have 60 hours of free compute to use, which means there's no chance that we're gonna run into the limit. So I like that. Also, thanks to the native integration of GitHub's file sharing system, I can easily send files to my students. They can access them in Codespaces without downloading or uploading anything. So that completely eliminates any risk of raising cybersecurity alarms. Finally, like Colab, Codespaces offers a native integration with an AI coding assistant. In this case, it's GitHub Copilot. Unlike Colab, GitHub Copilot costs $10 a month for an individual subscription, at least it does today. So that is not as good because Colab's AI assistant is integrated and available for free. But GitHub offers Copilot subscriptions for free to teachers and students, so I'm hoping I'll be able to take advantage of that. If you're not a teacher or a student, then you can get access to it for $10 a month. But I'm thinking that at least solves my AI problem. It gives me the option to integrate that whenever I figure out how I want to integrate it into my content. In conclusion, out of all the options that I surveyed, Codespaces is obviously the best solution for me. And the primary 2 reasons for that are that Codespaces offers way more compute than the alternatives, and it also solves my file sharing problem. Hopefully hearing about my research has been useful for you. If it has, hit the subscribe button, and I'll see you in the next video.